and one of those Indians who has received the highest honor that anywhere on the planet. So it just goes to show that I think being original, being creative, and being very having that insatiable quest for knowledge is going to play a very integral role in shaping up the future Nobel laureates. And I sincerely, from the bottom of my heart, feel that rather than looking at history, which should just give us some sort of pointers and guidance, I look upon someone of you all sitting over here one day to be the recipient of this Nobel Prize, and that will make this whole exercise really worth it. Next slide. Coming to a more futuristic look at the Nobel Prize, which are the domains which are likely to be really very challenging in the domain of Nobel Prize in physics, in physiology and medicine. Next slide. As my earlier speakers have also spoken about, there's been a very huge paradigm shift in our understanding of any domain of science, may it be computers, may it be medicine, may it be chemistry. Medicine, traditional medicine that I had studied maybe about 3 decades ago, and the medicine of today has radically changed its shape. It is all getting to the microcosm. Microcosm has been talking of the genotypes which were largely unknown for just about a decade back, has been totally decoded, the Human Genome Project. Medicine is moving down from the macro to the micro. It is coming down to the level of molecular genetics at the cellular level. So the way forward for any research and any potential scope for doing work for a Nobel Prize would largely be defined by understanding this paradigm shift which has occurred in medicine also. There is a very famous Professor Nicolette Bogart, who was the head of the Department of Clinical Physiology. And he said that we discover more and more biomarkers, get more technology to sequence more and more DNA details. So medicine is shifting largely from the macro to the micro. And if I were to go into the details of my biology, like mRNA, and the recent Nobel Prize for Medicine was given to a person who was doing work on mRNA, which is a messenger RNA. In fact, we all are familiar with COVID, and the preceding year the Nobel was given to a person whose work was largely instrumental in developing the COVID vaccine also in a very short and brief period of time. So this is just a bit of an overview of understanding how the paradigm has shifted from the macro to the micro, and this has to be kept in mind when we are trying to see how we can endeavor and how we can shape the direction of our research for the coming years. Next slide. If you look at medicine, modern pharmacology is very, very rapidly, what was earlier considered to be only chemicals, now has come to biopharmaceuticals, to nutraceuticals, and it's very hard to imagine that anyone who needed some medicine for, let's say, any infection, the chemical was the same for the entire human race, for that species. But now modern medicine, as the thought process has evolved, has come to realize that this will not work, and there will have to be a personalized drug delivery system. So pharmacology is also, modern medicine is now talking about a very personalized kind of a drug delivery system. It's hard to imagine that one chemical would be applicable to the entire human race for any particular ailment. So this is another stride that modern medicine is taking, and even biopharmaceuticals, which are